Hey guys, welcome to my video installment of Chapter 2, probably part 1 of Chapter 2, which deals with motion, okay? Motion in your physics book. So the first topic that they give, basically, they give a statement right out. They say, motion is relative. Now, let's dissect this a little bit. I think we all know what motion means. Kind of, we can say movement, right? I mean, that's basic. Now, relative. What, what can, what can we, I mean, I'm sure most of you know what this means, but let's dissect it a little bit. Let's think of words like related, right? Related or in relation to, right? Or maybe relationship, right? See, these words kind of have a common theme of, having a bond to something or tied to something else, or having having a close bond, right? I don't know the exact definition of, related, but you can think of maybe your aunt or uncle. It's your relatives. You're related to them. You're in relation to them, right? See how all these words come into play here? So that's what to think about when you say motion is relative. So now that we have a working definition of this statement here, well, how do we put it into use? What's the advantage here? So let's talk about that real quick after I change the palette color. Okay, so now that we know, I'll give quickly at the top, I'll give you a little definition again. Now that we know, motion is relative, means basically that motion is related to another object. So let's keep that in the back of our mind as I kind of give some examples. So if we have a car moving down the road, it's not a very good drawing of a car, but if we have a car moving down the road, and let's say he's moving 30 miles per hour, and let's say he's moving 30 miles per hour this way. It's maybe this way is north. Well, in everyday speaking, we say he's moving 30 miles per hour because he is, but really scientifically he's moving 30 miles per hour relative to the ground, which is important to know. He's relative to the ground, okay? Because as far as this car is concerned, the ground is going 0, so the resultant would be 30 miles per hour in the northern direction. So you have to consider when we're talking about things moving that they're always relative to something else. So if you have a plane, again, a plane would be moving, if a plane's moving at 100 miles per hour up in the sky, it's still moving relative to the earth because oftentimes, I mean, you're traveling from one destination on the earth to the other, so you're relative to the ground below. And then the last example that is important to realize is that even when you're sleeping in your bed, you're not moving at all, you're not changing your speed at all. See, here's the earth, right? Okay. You're not even moving, in your bed. Well, you are moving because the earth is revolving around its axis. Sorry, rotating around its axis. So it is moving, but then you say, okay, well, if the earth is moving, the earth is generally what we say we are relative to. So if I'm in my car moving 30 miles per hour, well, I'm relative to the earth, I'm relative to the ground. But if the earth is moving, what are they relative to? What is it relative to? Well, it's actually kind of simple. It's relative to the sun and the stars in our solar system, because those are the next, big, large masses. So when the earth moves, when you're not moving at all, but you want to talk in terms of motion relative, not relative to the earth, you say, well, I'm moving relative to the stars. And so then if you want to put a speed on that, you have to, find out how fast the earth revolves and stuff like that. So that's pretty basic. And now the next topic in chapter 2 is what it is speed. So speed, like the last video we talked about vectors and scalars, vector and scalar quantities, and speed is a great example, probably the most common example of a scalar, because it has a magnitude. It always has a magnitude, so it always has a size, but never a direction. No direction, right? So when we talk about, okay, well, I'm moving 30 miles per hour in my car, which is what we normally say. Normally say, okay, we're moving 30 miles per hour right now. No direction is specified, so we can call this a speed. This is always a speed. But then if we go back to, well, actually, I'll talk about velocity later. But yeah, so speed, see how this quantity has no direction, right? So you can always think of quantities without direction as speed quantities. And then now we also have kind of another way to identify speed, because it is a rate. So I don't know how familiar you guys are with rates, but that always means that something x is being divided by time, always. That's just the definition of a rate. So in terms of speed, our equation here is speed in s is defined by, or equal to, distance, total distance covered, over time. So if we plug in some numbers, let me clear the palette. I'll write the equation back up here for you guys to reference. Okay, speed is equal to distance over time. So let's say we want to know the speed. So speed is the variable, it's s, but we do have the distance, which is 10 kilometers, and we have the time, 5 seconds, okay? Now if we, just by basic math, we know that now the speed is 2 kilometers per second. The kilometers and the seconds you can't cancel out, you can't divide out, so they become kilometers per second. Now let's say we do have a speed, let's use these same numbers, let's say we have the speed of 2 kilometers per second, but then we only have the time. We have distance up here as the variable, and then we have 5 seconds here. Well, we can do the same thing. Well, we can just do basic algebra here. Just multiply both sides by 5 seconds to get rid of the denominator here, and 5 seconds over here. And so these cancel out. And then here, you can multiply the 5 and the 2, but the seconds cancel each other out. So then we have distance is equal to 10 kilometers. So you can just kind of mess around with the numbers to get the answer that you need. And that is it for, actually, yeah, that's it for this installment. There'll probably be a part 2 coming up soon.